Hey, welcome to the first episode of Christine and Dan's impromptu nerd out session. Today we've got an excellent episode for you, packed with a bunch of updates on some of our favorite things in the future of computing. Stay tuned because it's gonna get wild. Hello, guests. Here I am, Dan Finlay, with Christine Lemmer Weber, and we haven't talked in a while, and we thought we would catch up. There's been a lot going on at Spritely, and over at MetaMask, we're big fans, and yeah, and we're way overdue to catch up. I know there's been a lot of kinds of transitions. You've been transitioning into the new role as CEO, and I've been following some pretty cool updates on Hoot and the garbage collection and serialization and all that stuff, and all the changes to the WebAssembly platform that are coming as a result of your work. So really, really awesome stuff. Stoked to be supporting it as via our grants program, but really just as a user. I think a user in waiting. I like things that work pretty well before I use them, but I am just constantly watching the state of the project and fantasizing about using it. So, anyways, I always like to hear about how it's going. Um, cool. So, anyways, yeah, how have things been going?
Well, thank you for inviting me to this chat um, uh, with kind of which we really didn't fully decide what we were going to do on this, so I think we might just end up doing everything, which is
Yeah.
usually what happens when you and I have a call anyway. So like we
Yeah.
just kind of hop all over the place. So
Sure.
but things are going pretty well. As you said, there's been a lot of updates. We Spritely has kind of three big initiatives, and they're all kind of moving forward in major ways. Right now, Goblins is our distributed programming environment, and that's pretty exciting. And we just landed some new things there with our new persistence system. It allows for you to be able to serialize a running system and then bring it back later. Like you all were very big fans of object capability security and are constantly mining the ancient history of like E and stuff like that stuff. So the design is actually inspired by something that Mark Miller wrote about a very long time ago, called with an essay called "Safe Serialization Under Mutual Suspicion," and it went through a couple of iterations. I can explain it a bit more later, but the good news is that it also follows those security properties, and so that's really big. It took a while to be able to land, but it gives you some really powerful stuff, not only as in terms of serializing things, but also a really powerful upgrading mechanism. And in our case, also a really cool way to actually make live development even better. So you can kind of like code changes to objects and then say, hey, upgrade all the objects that would be affected by this change. And live, while you're programming, it goes in and grabs them and like changes them and they keep running. So you could be in the middle of a game and like have a bunch of characters moving around and stuff like that and make some pretty fundamental restructuring and it'll like kind of like like try to serialize it and bring it back in this new upgraded form.
Like those
So
bad guys
there's
have hats now or something, for
what's oh
example.
yeah, the bad guys have hats now, exactly.
Hmm.
So we so Goblins is our distributed programming environment. That persistence thing is just one part of it. There's many other parts we have to it. The Since it's a distributed network programming environment, one of the interesting things about it is that when you write code, you kind of by default get code that works with distributed, like to be able to be networked and distributed. Like you get a lot of that for free by developing stuff on top of Goblins. So that network protocol is in kind of pre-standardization effort. It's called OCAPN, the Object Capability Network. Of course, you and I have talked about that a lot, and our friends over at Agoric are also participating in the process. And we've also got some friends from like the Sandstorm and Captain Proto community who have been in there, and a number of
Yeah,
community members.
Cloudflare. I
Yeah,
saw they had a new object serialization and transport.
yeah, they're doing a little bit of different stuff, but there's communication with the people who are involved in that. and those teams. And so one of the things that we're trying to do is basically that's the network protocol that connects all the Goblin stuff together, and we're trying to make that something so it's not just our tooling and it's not just a Agoric's tooling. It's stuff that you could have many languages talk to each other, and kind of have this global network of intercommunicating stuff. So we Jessica Talon um, found like who took a bunch of that technology and kind of wrote it down into specifications so that anybody can pick it up and read it and implement it and run tests against it and stuff like that. So those documents have been moving along. The conversations and the standardization process, or pre-standardization process we call it, have been moving along. And then the other big initiative is Hoot, which is what you all have been generously funding, which is our Scheme to WebAssembly compiler. It's the short version of it, right? So all of our stuff is written on top of this Lisp dialect called Scheme. And it's really powerful. It allows us to do a lot of these things very fast and efficiently, and be able to develop um, things that would, in pretty much every other programming language, be really difficult to engineer. We can get done very efficiently, but you want to get things to users. And so we have this project called Hoot, which is what's being funded by the MetaMask Grant program. And that project is not actually just a scheme to WebAssembly compiler, but it also includes an assembler. So you can actually use it to assemble low-level WebAssembly stuff. It doesn't use mscripten or anything like that. It doesn't use LLVM. It actually is all that tooling is written in Scheme. It actually includes a disassembler, so you can take a compiled WebAssembly program and it can break it apart into pieces and show you what's actually happening in there. It also
Whoa.
includes a linker, and very interestingly, it also includes a full WebAssembly virtual machine so that you can write Scheme code. It can compile it to WebAssembly, and then you can actually run it in in without leaving your development environment at all from
Whoa.
the REPL.
So
So
you could like compile a WebAssembly module within the Scheme environment and instrument it, or actually one thing that I've wanted for a long time would be like metered WebAssembly. So like, could you just I'd imagine once you're in Scheme, you could kind of trivially throw a counter between every operation or something.
we
Um,
haven't done that, but actually it would be our virtual machine's not set up to do that, but it would be pretty easy to take the virtual machine we have and instrument it to do that type of thing.
right.
I mean, the virtual machine we have, it's actually not meant for use. You
Hmm.
can use it for it, including for things that are not Scheme compiled. Like we actually took a game there's this game, like fantasy game console called WASM 4, and we took a game that was not written in Scheme but compiled to WebAssembly, and this has never actually been shown publicly, but
Hmm.
David Thompson actually just hooked up the equivalent interface that you have for like that little fantasy console of like, here's how you play graphics, here's how you do that, and it worked. Like
Wow.
like it actually was able to run that, not fast, it was super slow. But the reason we have it is not because we want to have it's not designed for efficiency, it's
Right.
designed for development, right? So it's a developer's virtual machine. So it actually runs things, and it runs them at a with a lot of information, so that you talked about instrumentation. It's very focused around instrumentation for understanding what's happening. So you can actually not only run things and debug them when they go badly, but you can actually, even though WebAssembly is a low-level compiled language, right? It's a binary format after it gets compiled onto this expression. It has this textual representation, which we love because it's Lispy looking.
Hmm.
But you can, but what's interesting is that even in a running program, you can actually insert WASM code while the program is running. You can actually say, the same way that, at your JavaScript console, you might be like, I wonder what would happen if I did this and then did this. You can actually do that with low-level WebAssembly in our
Whoa.
virtual machine, which is pretty cool. I mean, I don't think anybody else is really using it for development, but we use it all the time. And so it makes developing this stuff really easy because, you know, when you're emitting WebAssembly and something goes wrong, you actually have the tools right there to be able to see, oh, okay, well, here's what the stack is like, here's what's being called, here's what's everything. And let me just try seeing, since this code is obviously wrong, let me try poking at this and inserting the next few things that I think would be right. Okay, now I figured out what it should be. So I say all that without me actually working on the Hoot stuff every day. The main people who work on that every day are David Thompson and Andy Wingo, and we
Mm.
also have Juliana Sims is very actively actually working on another thing I have not talked about yet. So this is the big thing. I told you there was a big piece of news that literally happened
Okay.
today. Here's the big piece of news. Julie has been working on getting goblins to compile with Hoot. And when I
Yay.
Yeah. So when I wrote Goblins was originally written in Racket, which and was
Mhm.
ported to Guile, which are two different types of schemes.
Right.
And but when I did that originally, I decided to do it in phases. I did, you know, phase 0, phase 1, phase 2 of pre-goblins, I called it, so that we could understand how goblins really worked if we wanted to port it to another language. So what Julie actually did was compiled each version of pre-goblins, and actually each phase of that revealed different really interesting structural bugs in
Hmm.
Hoot,
Hmm.
because, you know, it was kind of the first really big complicated program being done on top of Hoot. We'd made some
Right.
games, we'd done some other types of things, but this but it revealed, actually it even revealed a bug, maybe even two, in Guile itself, actually, that was hidden deep inside of the
Wow.
compiler. Yeah, that's pretty cool. Um but anyway, she got through all the pre-goblins phases last week. Well, the big news today
Mhm.
is that goblins core.scm compiles and runs in the browser with Hoot. That is the big
What?
news. Yes.
Why are we talking? Why aren't we exchanging objects over a browser session? Yeah.
Right, right. Yeah, no, it's really exciting. Now I should say this is core.scm. So this is like the core part of goblins. There's
Mhm.
actually several layers to goblins to be able to get them, and I actually expect that all the other layers are going to come pretty fast.
Cool.
The first layer is the core stuff, which has so I mentioned that goblins is a distributed object programming environment, but it's actually
Mhm.
a few other things too. One of the interesting things about it, and if you've seen some of my talks on it, you've probably seen the flashiness of this, and I can show off the flashy demos if people want to see them. But and the people being, it's just you and me on this call. Who knows if future people would want to see it or not? But like there's this demo. Um, Maybe it's better if I just showed it. Well, no, I'm just going to explain it. There's demos we've shown off of, like the space shooter game I wrote that like
Mhm.
runs in a
Terminal phase.
terminal. Yeah, terminal phase. And like there's time travel, right? Like you move backwards and forwards in time, you know, kind of like if you've played like with like a Super Nintendo emulator or something like that, you can save states at previous points and jump back.
Mhm.
Um, that so that What's actually interesting about that is that it's actually using Goblin's transactionality system for that time travel.
Mhm.
So there's kind of this low level distributed, before you get to distributed, just the object programming environment, which is what provides the transactionality and stuff like that.
Mhm.
That now works. So that now works in the browser. So if you could actually
Cool.
write terminal phase like
Nice.
games
So you
in
could
the browser
do
today.
that. Does that even include like say serialization? Or it would mean like at the very least we could have a single transactional process where we could do, yeah, forward and backward rewinds, taking
Right. So
advantage of the transactionality.
you can do the forward backward rewind. The In order to simplify things, Julie had commented out all the persistent stuff
Right.
and
Yeah,
sent
yeah,
it
because
out.
that's going to be some kind of like system interface. So that'll be a later phase. That makes a lot of
Well,
sense.
it's probably going to come pretty fast. Actually, I think it's going to be there in the next week or so.
Neat.
It's happening really
Cool.
fast.
So
So now
potentially
that
within a week, you'll be able to play a space shooter, reload the page, resume from the exact spot you're in, and rewind to an arbitrary point in the game.
That's right. Actually, very recently, I just added. We have a blog post that's about to come out about this. It hasn't happened yet, but I just added. Um, Actually, in the latest Goblins release, if you look at the blog post, it shows an image of this. But I just added the ability to save a terminal phase game while you're playing it, right? And it actually
Mhm.
uses our serialization system. So it actually serializes the level, like the level manager and the level and all the ships and all the bullets and everything like that,
Hmm.
saves it, and then wakes it right back up. Um, the interesting thing about that actually was that once we had ported everything over to the new serialization system, we were kind of shocked. Jessica Talon, who had done the new version of the serialization system, and I were on a call while I was getting the last final pieces of it working, and we saved it and then restored it, and it actually worked. Like, we had shut down the process and bought it back, and we were just like screaming with excitement. Like, it's
Yeah.
just so exciting that, like, oh my gosh, it worked, right? So that that ability to save things, it will be coming in pretty soon. Julie's working on porting that. Um, the um, the bigger, more complex part is actually the networked part, right? So,
Hmm.
like, getting the network programming stuff. And actually, one of the bigger tricks about that is actually the cryptography part, right? Making sure that we have the right cryptography primitives hooked up and everything like that. Um, there's actually a low level set of browser APIs that we were debating, should we use a JavaScript library? I mean, it feels a little bit silly because we just managed to not have to have a bunch of JavaScript stuff, but we could
Hmm.
use a JavaScript library. Should we use something that we compile from using mscripten and from C? Should we be using, like, what should we do? But it
Hmm.
turns out there's a new set of browser cryptography APIs that are the, like, web crypto stuff, and right
Hmm.
now they're exposed as the, like, what do they called it?
Subtle
Um,
crypto.
the subtle crypto stuff. So we're using the subtle crypto stuff as subtly as we can,
Hmm.
and
Yeah, it's named such basically to try to scare you when you're using it because the implication is you're using such low level cryptography primitives
exactly.
that using it correctly requires subtlety.
Right, exactly. So, but we already know what we're doing on the other side. So what we're going to
Mhm.
just try to do is, like, get API compatible stuff from what we have on the other side of things. So, but that it, but yeah, the subtle. You're exactly right about the subtlety. I think the cryptography world correctly tries to spook people about, like, it's very easy to get this stuff wrong. It can happen a bit too much because sometimes it discourages people from getting into the field, like it
Mhm.
discourages people from learning about how cryptography works.
Right.
Um,
I think there is
but
also a browser API just called crypto where all the methods exposed are like pretty much kludges and it's hard to get it wrong. It's just like sign and decrypt and verify and hash. Subtle crypto, I know one way that I misused, for example, was one time using a hashing function. They let you pick how many iterations of the hashing function. And I hadn't really
mm,
experienced that before, but what you're basically doing is you're choosing the difficulty of a little proof of work because somebody trying to crack that hash later will be trying to perform that many hashes times how many attempts they're going for. So like
right,
that's an example of the type of foot gun that you're getting in around. It's not impossible or insurmountable, but it could benefit from like running it by a cryptographer just to be like, is that how to use it? And they might have
right.
some thoughts. Um,
Yeah, yeah. No, I think it was the right move to call it subtle crypto.
yeah.
Give people the right impression. But anyway, that's all moving forward.
Yeah,
I think that we're
just kind of out of curiosity, there's like it sounds like you can probably swap that around later if you want, but have you made any decisions about which types of cryptography you're using for the sessions for now?
well, right now we're using elliptic curve cryptography, and if I try to say the names, I will get it
Sure.
wrong. I think it's like ED5 something.
Yeah, yeah,
From
the ed 85519 or something.
Yeah,
Um,
whichever whatever that
yeah.
number is and stuff like
Right, the
that.
one
I'm
that's
not good
provided by
with.
the browser. It's not the Ethereum key because the browser, which is also the Bitcoin key, because there are some browser politics. They didn't like crypto, but
Oh,
there's
really? Is
some
that
there's some
why?
very similar equivalent-ish curves, is my impression, provided by
Okay.
the browser.
Yeah, I wasn't. Uh, but yeah, we're using. Pardon me. Really needed to cough in the middle of that. We're using elliptic curve cryptography, and actually we're not super settled on the cryptographic primitives that we're using there. I think we have it's something that we'd like to get stronger review on in the OCAPN group. Is kind of like come to consensus on what particular we're making it flexible so that you can change those things out as cryptography needs change, right? But you
You want a good
obviously want
default.
to launch with the right things, right? And
Yep.
so right now, I will say that that needs more review than it has currently gotten. But I think that, um, but I'm sure that that will be. I mean, that's something that we have kind of in the queue of trying to find some people who we can get a security review from that particular part of things. But
Yeah, cool.
yep.
Cool. So yeah. So right, once we've got the initial transactional layer and the serialization, then we're getting into peers of these things interconnecting so they can share object references across the network or process boundary.
Hmm.
Um,
Hmm.
and that's the protocol that is OCAPN, or is it you're
Hmm.
hoping it evolves into OCAPN? Um,
No, it is OCAPN. That's what we call it.
cool.
It's in a it's OCAPN. The current version that we have is acknowledged as like a in development. There's not consensus on all the key components of it yet. So we have a test suite. There are community implementations that are passing the test suite and stuff, but we don't have group consensus that this is the way we want to do all those things yet.
Mhm.
So that's all still moving forward, and we're still kind of coming towards settling on all those parts.
Cool. Yeah, I know as of what last Friday, so like 4 days ago, Agoric did their first, or no, I guess 6 days ago, Agoric did their first demo of their endo processes performing multiplayer.
Oh,
And
nice.
so they're I mean, they already had their JavaScript CapTP, which is kind of like the thing that, we hope to make compatible with OCAPN. But this was their first time, I guess, having two basically transactional machines where they're deterministic, like Spritely machines, intercommunicating. And I guess for any viewers, like these are very similar environments. They're approaching the problem of distributed object sharing from different implementation and resulting environment perspectives. But if we do it right, we'll be able to share objects between them, and so then developers will basically be able to choose the environment that kind of suits their needs, um, uh, which is just super awesome.
Right, and you'll be able to leverage the right parts of the different stacks that you have, right?
Mhm.
So right now, Spritely stuff is very focused on social side of things.
Mhm.
Agoric and MetaMask focus much more on the financial side of things, right? And and actually everybody there's overlap between these different things, right? And certainly I think I saw you go and it's not as
Yeah.
if they're
Right.
you're
It's
not
like it's
focusing
like
on the social side of
I
things.
yearn for us to be able to support more social things. But you're completely right, right? We're a crypto wallet first. Like people like you ask our users, what do you use it for? 99.99% of them are going to say, well, holding tokens, trading them. The most advanced or sophisticated users might be, pooling them into a DAO where they like vote with others on how to spend them or allocate them, or, then there's the NFT community and things like that. But these are kind of inherently um, because blockchains today are like such a large consensus machine, the transaction fees are so high that the only use cases that there really is room for are ones where each transaction is like got some value or weight. And that's why like I think NFTs, right, it kind of emulates the art market because well, every transaction in an art market is actually like a big deal. It's like, oh, someone got a Van Gogh, ooh. But in Sprightly, yeah, with social in your sites, yeah, you need transactions to be as cheap as the stars move in a space shooter. Um,
Right.
it's a
Yep.
very, very different environment. And I think the like Ethereum community has been warming up to like the notion of like, maybe not everything has to be on chain, particularly through Warpcaster, which is like this kind of the Ethereum rooted social network right now. It's a very similar to Blue Sky Protocol, except that basically your signer for your account, every post and stuff, it's defined on the Ethereum blockchain. So it's kind of like they're using the blockchain as like an access control rotation mechanism, but then they're basically keeping everything else in effectively pubs, but with that kind of like new generation advantage where, which is to say,
It's kind of a
what?
it's kind of a DID type approach then, if they're doing the
Right.
identity on the chain, I guess.
Yeah, I think they're kind of trying to do. I think this is similar to what Blue Sky's claiming in that they claim like identity portability, right? Relative
Mm.
to, and you would obviously be an expert on whether this is actually a differentiator relative to Activity Pub, but they're claiming, well, and I've experienced and seen others experience once you've created an account on an Activity Pub, right? Like your account is with that admin, and sometimes the admin decides they don't like you and you lost your history or whatever. Um, so I think that they've got account portability of some sort. But anyways, that's aside from the point. The cool thing here is, okay, yes, we're coming from the financial avenue, and then you're Sprightly and Endo are showing this. Well, what about for transactions where you don't need any consensus at all, where this is
Right.
your object, this is your program, this is your file. Then what is the lightest weight thing we can have, and what's the most performant thing that we can have, and what's the friendliest developer environment? Because now we're talking about no fees, we're talking about personal development environments. The just I think the stakes and the mentality and the constraints are just incredibly different. If I'm sitting down and I'm going to write an Ethereum smart contract, I'm thinking things like, oh, what's the most impactful high leverage single thing, right? Versus if I'm in a Sprightly or an Endo environment, I'm more thinking like, oh, what's the little utility I need today, or and so there's like it feels like it's a kind of an inherently more personal starting point for writing computer code.
Yeah, I think I mean, so you can use all these in a certain sense. These all move towards kind of a I mean, there's a bunch that people have kind of spent thinking about, like, what how different are these layers of
Mhm.
things, like where I as you know, I'm not as attached to the blockchain type space. I come from the activity pub background and stuff like that.
Yeah.
But the but a lot of but I am interested in being able to have replication of things, right? And in a certain extent, I think there's that a blog post I wrote a while ago that was called, like what, beyond the shouting match, what's a blockchain? And it
Mhm.
had like 10 different ways of looking at what a thing could be. And there's some of those that like they're just not within the realm of the things that I really like focus on. And then there are some
Mhm.
that like actually are a lot more interesting. So one of them could, for example, is if you wanted to have is there's a certain amount of consensus that might be about getting um, getting basically a quorum of machines to have replication, right? Like a replication of state,
Mhm.
right? And the having a small quorum of things actually get replication um, is something that Goblins is actually very good for. We haven't used it to the extent that I would like to show it off. Like one of the things
Mhm.
that I would like to show off is a multiplayer version of Terminal Phase where you have multiple people connecting and this is what, like, if you do the multiplayer thing on like like a Super Nintendo or Sega Genesis emulator or
Mhm.
whatever, and you have you and your friend playing the game over the internet, what even though that system was not designed to have multiplayer, what it does actually is it's just saving, it's doing a save state, right? It's doing saving old versions of the thing where you two both did have agreement on what all the inputs were, and then you both kind of play the inputs about locally from what you're doing, and then send the inputs that you're doing to the other side, and then when you both get each other's inputs, then you fast forward, right? Like the thing invisibly fast forwards playing all of your inputs at the same time, and then gets up to the point with where you're caught up, and then it looks, you're able to keep playing without lag. You don't have to sit there and wait for somebody else's packet to come in. So you can end up
Mhm.
having, this is how a lot of multiplayer and a lot of like online games actually works.
Mhm.
But the but I would love to show that type of thing off as like, because one of the things that is really important is, it may actually, I think a lot of people worry about resilience, and rightly so. And there's multiple ways by which you might achieve resilience, and it's really dependent on your use case, right? Like what, um, uh, and I'm kind of rambling here a little bit, but but I think that one of the interesting things is that I know that the Agoric folks are very interested in using endo in blockchain oriented spaces, right? So the idea that that type of stuff is not just, it's not specifically at any one of these specific layers of abstraction. And for them, they perceive, per my understanding, I don't mean to speak for Mark and Dean and everybody over there, right? But
Mhm.
per my understanding, what they perceive of the blockchain as being is, something that has a bunch of replicated machines, but then also has this global consensus sitting on top of it.
Mhm.
So which of those parts of the puzzle you need may really vary, but part of the key thing is, the shared computation, the underlying computational model, if it's got the right transactional abstractions, can actually possibly scale up and down depending on what kinds of guarantees you want to provide. Do you need something cheap? Do you need something that has high replication? Do you need something that has, that has who gets to agree on which events have occurred in the system? Those are all different decisions you can make depending on your particular use case.
Yeah. Yeah, I love this topic of kind of like how to scale up the trust assumptions of a program. Because
Hmm.
you could imagine, oh, I start playing terminal phase by myself, and that's all nice. And then maybe then we play a co-op game and it's very friendly, and we're basically using the Unum model where we're just
Hmm.
kind of like replicating each other's chips on each other's machine because we have high trust and we're just playing along. And then what if then we decide to maybe there's a versus mode and we want a little wager, or there's a high score thing. So now do we need an escrow server? Do we need to each sign each other's packets before committing to our own? Or,
Hmm.
like you start to get into this weird space where immediately it starts asking the same questions that like a blockchain would ask. And I'm really interested in both what is the minimum necessary consensus for a given use case, and
Hmm.
and what would it take to have a programming environment that kind of bakes that in intuitively into the environment so you're not constantly trying to like assay the value of a function or something. Like it'd
Hmm.
be really really interesting to just ask like what would it take for the syntax of the language to kind of naturally express like, well, this thing needs, we both care about its outcome. For like
Right.
would like a sense of distrust be like a syntactic character wrapped around a function or something, or like don't take my word for it kind of function. um
One of one of my favorite protocols happened a long time ago, like called Lockstep. It was one of the first really interesting protocols trying to avoid a cheating in online multiplayer games, and
hmm.
it's really interesting and easily understood in the case of a simultaneous play turn-based game. So, like for
Hmm.
example, I don't know, have you ever played the game Robo Rally?
Yeah, Robo
Yeah,
Rally's
isn't that game
great.
great?
Yeah,
Okay, let me, just in case, I don't know if we'll have any listeners or not, but just in case
sure.
we don't, I mean, just in case we do,
Hmm.
it's a game where you have these different robots and they're moving around on the board, and you're basically like ha writing down code. Like you're basically playing cards which are code of like, move forward, turn left, turn right, and everything like that. They're instructions effectively on the movement of the character.
Yeah, and if
Kind
you've
of like,
played if you've played Mechs and Minions, it's totally like drawing directly inspiration from that, but then giving it the Riot treatment of high production value and a little bit more sophistication in terms of the cards that you have.
I
So
have not
that's
played that one, but that sounds interesting.
it's like a legacy game too. It's like a 20 level game, and it's
Ooh.
a four player co-op.
I
Pretty
love
pretty
legacy
fun.
games.
Yeah.
But the I but what's happening here? So what you might ask is, well, how can we do this and have it be multiplayer? Because the risk is that if you're both playing cards simultaneously at the same time, there's the possibility that if let's say your character is right here and then there's like a gap right here where it could be pushed into, right? And your character would like to rotate and move this way, but or something like that. But there's a possibility that if I choose to move forward, I could shove you into the hole, right?
Hmm.
So you can choose like, well, do I want to advance towards this thing that I want to pick up, or do I want to do this other thing? And so knowing what the other person is going to choose to do, Not knowing is what a lot of it makes the game fun. So how
Right.
do
You
you
kind of
allow
need a
both?
commit reveal like frame by frame or something.
And
It's,
exactly, that's exactly what the what lockstep does, is that you actually both hash your inputs and share them with each other,
ah,
and then acknowledge having received each other's hashes, and then you both reveal what the actual move was,
hmm,
and you've both committed to the hash. So at that point, you know that the other side actually signed off on this being the
yeah.
thing that they did.
So
Neither person gets to take advantage of the knowledge of the person who submitted first.
this reminds me of what they would call a plasma chain in early Ethereum scaling development. And the attack they ended up deciding it was fruitless because of was data availability. Because if you ever hash a move that results in you dying, you could just forget the packet that it hashed and oh, I'm offline now. Now I guess you could just say there are liveness requirements and you can only win if you stay online, but you could never tell somebody going offline, for honest reasons from a person going offline because they were about to lose.
Well, this type of problem has been in online multiplayer games for like pretty much forever. I don't know if you played. I mean, I'm definitely showing my age, but I played the first StarCraft when it came out.
Oh yeah.
And like on Battle.net, which I
Hmm.
didn't realize till ages later was basically just IRC, and like
With it,
like
with like a slightly variant ELO system stacked on top of it. Um,
yeah, and so I would, you'd go on Battle.net to play a game, and um, you, if you're playing against somebody else, if they were losing, they might just, quit, right? If they want, and so they very quickly put in a thing where were like, well, if you quit, then it's considered that you lost. But then,
yeah.
everybody was playing on 56K modem, so like, they're like,
That
well,
kind
we
of
don't want to
solves
punish.
it, right? Yeah, because it's like, okay, yeah, we may never be able to say that you didn't lose or or that you lost for sure, but we'll count it as a loss. Sorry.
Yeah,
Yeah, yeah, and yeah, so if you have a bad modem, that's on you. Like get your infrastructure together.
if I
Um,
remember correctly, initially they didn't have, like, they made a distinguishing thing between quitting and being disconnected initially.
oh,
And so if you disconnected, it wouldn't be held against you. But then, of course, people just started pulling their
yeah.
connection out of the wall when they were about to
Yeah,
lose to
I
start
think I
quitting.
remember us witnessing someone do that once or twice.
And I
Um,
think when I was playing it, this may be me completely misremembering because this is 2 decades ago or whatever, maybe even longer. I don't even remember. I don't want to do that calculation.
mm,
The I seem to remember that they started doing a thing where if you got disconnected, um, they would start warning you. Like if you did it too many times, they would kick you off the thing. And I noticed that they still do this today. Like I played Smash Online for a while,
mhm.
and in Smash Brothers, if you disconnect too many times, they start warning you like, "Hey, we're gonna kick you off the system." And
Right.
it's hard to
So basically, penalty for going offline is kind of
exactly,
a
yeah, yeah,
solution. Yeah.
yeah. So yeah, it's and as you said, it's hard to distinguish between those cases, especially if
Mm.
somebody like wants to. Um, so you don't want to punish somebody unfairly, but you might have to punish somebody unfairly, I guess.
Yeah.
You might at least have to do the middle ground.
Yeah.
Of
I'm trying to think of why it was like definitely a worse situation in blockchains. I think it was I don't want to speak out of my expertise. I don't remember the exact details. Maybe slightly different, but the validators all have potentially public IP addresses, so griefing them is easier versus most video games. You're either talking to a central server or maybe in this case perhaps to each other. Um,
Mhm.
but yeah, yes. So a commit reveal to each other, and you're just like, if you disconnect. Now, if it's just between the two of us, yeah, it's only honor between each other.
Right.
So you could just always say like, I count that as a loss because you disconnected.
Well,
And
I mean, I played plenty of chess games when I was in like high school where somebody would just flip the table, right?
right,
That's like pretty much the same thing. And then if they flip the table, I mean, what's the consequence with that? I don't play with that person anymore,
right,
right?
right.
Like
It's
I'm
at
like,
least a reputational damage, and honestly, that's probably worse than a loss, really. Like if so, I mean, it's interesting because it brings it to it's kind of a little social collateral thing, which is a concept that I'm fond of, and that actually kind of led me to object capabilities. But yeah, it's like the value of the game to each other is the thing that kind of ensures it. So
Right,
if you value our relationship more than this game, then we should probably be able to rule out like malicious disconnects. Um,
right, right. Yeah. And sometimes I guess maybe this is less true in a blockchain context, but I think it's true around the gaming table. I mean, one of the things that has been true for me is realizing just how much fun it is to lose, right? Like losing is a great opportunity to learn, right? When you lose, it's like, oh wow, this is really cool because like why did I lose? And this is really interesting. And and you can think of it this way, when you lose in a board game that you were really excited about, that's kind of awesome because you got a lesson out of that from somebody else, right? Like you actually got something of value out of it. You got something that you can take away and consider, and you're like, wow, I had a gap in my approach and knowledge, and now I have a new thing that I can actually, try to take with me and analyze and try to bring to the next thing. So losing can be great. Losing is I guess you could say losing's the path to success in that type of way, right?
yeah, yeah, yeah.
Um,
Classic Edison insert Edison quote about light bulb creation. Uh, um,
uh, but yeah, I guess I'm suddenly not sure what's the interesting jump off topic from this point.
mm.
Um,
Okay, let me just make sure that we bottomed that out real quick because it's like I honestly think that it's a really interesting topic, and I mean we're not going to bottom that out, but you had just touched on we were talking about kind of that spectrum that's going on between these distributed object systems, between the like no consensus needed total initial sprightly model going up to like the heavyweight Ethereum blockchain model. Oh, I had one little aside question that I kind of wanted to ask. Like since Lisp is a pretty simple environment language, let's say, um, sometimes every once in a while, I think to myself, maybe I should write a Lisp interpreter on the Ethereum blockchain so that you could. I wonder if you could have at least a subset of a Lisp environment or something. So then you could take at least very simple scripts that you needed really high integrity for in Spritely, and you could, there could be a function that says like elevate this all the way up to a worldwide consensus. We want really good availability for this one, and then we could have a really simple interpreter over there that's running that function.
I mean, if you could also actually even kind of take it half offline in the following way.
Mm.
I haven't really thought about this before. I'm thinking out loud. Um, if you think about so the object capability security approach to event loops is to call them VATs, right? Because
Hmm.
there's a specific kind of event loop thing that we
Yeah.
call a VAT, but it
It's
really
it's
is an
kind
event
of
loop.
like what most people think of for a thread or a process, where it's a single threaded thing, and it talks to other single threaded or other VATs, and but with this special property that they can exchange object references in the parameters of each other's functions.
Right, and you can get into some distinguishing things between what's the difference between VATs and actors and stuff like that, but we won't do
Mm.
that for right now unless if we choose to after this.
I mean, it's
Um,
basically whether the parameters can be objects, right? Like pointers with unique identity versus just being
okay, so
data,
we
right?
are going to get into it.
Okay, I'm sorry.
Uh,
I'm sorry.
actors have the ability to exchange messages with each other too.
Yeah,
The
no, but
distinguishing thing,
object references, like a function, a first class function, let's say. I think that's a pretty good distinguisher, right?
um, there's a lot. This gets into a particular special interest of mine, which is the difference between actors and VATs in the
I
Lambda
know.
calculus.
I know. I
Yeah.
feel like that's part of why you're the perfect person for me to bounce that framing off of.
Okay. Well, I had an answer to your question, so I will.
Mm, you take
I'm
it in
gonna
either order.
I'm gonna take it in the other order. Okay. Um, Let me answer your first question, and then let's get into what's the difference between VATs and actors.
Sounds good.
Let's do that. Um, So the first one is, could you put things on the Ethereum or whatever blockchain? And you certainly could take something and put it on the Ethereum or whatever blockchain, but you might actually be able to put something more lightweight on it and still
Mhm.
get the same effect.
Mhm.
So let's say you had, I mean, because the question could be, do you actually need to put the code on it at all? If you wanted to have a series of events that you agreed upon as going into the VAT, you could
Mhm.
just commit the messages that the VAT receives. And
Ah.
that's all you commit, and then have all the
Mhm.
code run offline. And then
Mhm.
you don't actually need to do the expense of running that code on the Ethereum blockchain.
You've nearly reinvented what they call optimistic rollups in the Ethereum land. The one property that I think they would add is in the case of dispute, the blockchain needs to be able to tick through those messages to like find who is right about it. Otherwise, it's
Okay.
just a message store.
I'm so naive about any blockchain things that I
Yeah,
can't
yeah,
comment on
I'm
that.
super excited to be able to share a concept
Uh,
with you.
but no,
You haven't heard
it's
it.
I mean, good ideas end up being emergent from multiple contexts,
Mhm.
right? Um, so now actually let's use that as a tie into the next thing about what's the difference between actors and VATs, and let's throw in another one, the lambda calculus, and
Mhm.
how does Lisp and Scheme come into all of this? So um, most um, most of us write code in kind of sequential programming language things. You're calling a bunch of functions, maybe having, like kind of like more traditional objects that are like localized, on your machine. But you're really invoking procedures that you pass things around to, right? And they return things. And there's, you know, you can get very fidgety about whether or not this is correct or not, but you can translate most of that into this thing that's called the lambda calculus. And this is why you
Mhm.
see the lambda symbol appear in the logo of a billion programming languages, is because, people find out about this and they fall in love with it, and for good reason. And,
It's deeply
so
expressive. I
it's deeply expressive.
I've recently I'll just briefly insert like one way of framing it because I had a recent kind of Lambda epiphany. I was listening to a talk by Noam Chomsky where he was talking about Turing completeness and language completeness, and um, and in it he basically was saying like the thing that makes human language interesting is the fact that you can express any idea with a limited syntax, and that's also what makes Turing completeness interesting. So like computer completeness is interesting for the same reason human languages and lambda calculus and kind of extending into the whole object capability paradigm for me is kind of like a very very unambiguous computer way of expressing just with the simplest possible syntax ideas. It's like arguably it's the simplest of all possible syntaxes and while being safe, as in your words have meaning, the meaning that you assign to them always. And
Right.
so the simplest syntax that is local to you, while still allowing interconnection between individuals who while having their own local syntax and language, are able to actually talk about the same things. Just seems, yeah. So yeah, it feels like deeply profound for the reason that it's the simplest way we can say anything and automate it. Like I don't know. So
It's
yeah.
it's amazing that even with just a lambda as terms of just being an anonymous function, and I actually sent it to you, and I have not published this anywhere yet. We've
Mm.
had it queued as like a thing to publish later, and we never did it. But you may remember I was working on this blog post that was called Lambda the Ultimate Everything, and it's basically showing off church encoding and stuff like that, like how you can
Yeah,
make integers out of
just
lambdas, and how you
lambdas.
can
Yeah.
make if out of lambdas and stuff like that,
Hmm.
um, and um, and booleans and stuff like that. It's amazing just having lambdas. You can make everything else. It might not always be the most efficient thing,
Right.
but you can make everything else, right? So the integers you make out of lambdas are not the most efficient
Right.
integers.
It's
They're
like a
ON.
list of the next integer,
Right,
basically.
yeah, yeah.
Yeah.
They're basically tallies, tally
Yeah.
marks, right? But the lambda calculus is powerful enough that you can express all ideas in the lambda
Mhm.
calculus, which is, I think, that where what's really important here.
Yeah.
So the next bit then is, what can you do in terms of, what was the next part? Right, the next part is that Lisps traditionally have been in that kind of lambda calculus history, right? In
Mhm.
fact, in many ways, kind of did a lot of pioneering in the lambda calculus type territory. Now, the actor model seems to have a lot of similarity. Instead of it being procedures which can take arguments and then return other things, right?
Mhm.
It's you have these entities that almost seem like alive, right? They have like you have these. You could say they're objects, right? The whether or not objects and actors are the same thing is a thing up for debate. But you basically have a thing with an address, and you can send it a message, right? And the actor model, you have these different actors, and it's like a society. Carl Hewitt described it as like a society of experts, all cooperating together, right? And they're all doing these different things and cooperating, right? And so you have all these different actors, and the way you communicate with them is that you have some sort of address to this actor, and you can send it a message, right?
Mhm.
And then the actor, upon receiving a message, can only do the actor model only requires it being able to do three things, and everything else emerges from
Right.
that,
Create
right?
other
So
actors, send messages, and change or
yeah, change your
yeah.
behavior in response to the message. Change your behavior for the next message, right? That's right.
Mhm.
Yeah, create, send to what you know about, and change your behavior. That's all. It's required to do all computation in the actor model.
Mhm.
Now, the actor model is great since you're sending messages. It's really great for these big distributed systems where it doesn't matter where anything lives, right? Whereas it's very different if you're writing a sequential Lisp or JavaScript program. You're expecting to do this and then do this and then do this, right? Um, and so um, the story of Scheme, the programming language that we're using, is actually the story of kind of a rift between a rift between the philosophical positions of kind of the Lisp community and, let's say, the actor community,
Hmm.
and kind of actually bringing them together in a way. Um, uh, Jerry Sussman Jerry Sussman and Guile Steele, who later worked on Java and some other things, were and was also co-author of the Common Lisp
Hmm.
specification. And they were trying to understand what Carl Hewitt was talking about. Carl Hewitt, very interesting person, unfortunately passed away recently. I did have the fortune of getting to know and speak to Carl quite a bit.
Hmm.
And sometimes a challenging person, but I did walk away sometimes feeling frustrated and challenged, but also sometimes having new things to think about, in conversation with them that really shaped a lot of my thinking.
Hmm.
So one of the what Carl what Sussman and Steele were trying to understand actors. They were specifically trying to understand this system called planner or microplanner. So planner and microplanner were implementations of actors, and there had been some incredible demos built on top of them, including this one called. There's a great talk by Quinn Wilson called about Shrudlu, I think. I can't quite pronounce it right, which is
Hmm.
about this amazing and early AI robot that
Hmm.
manages to do all these. You give it commands like go, pick up the towel, now place the towel on top of the circle and stuff like that. And it did all these things in the 60s or 70s.
What?
I think in the 60s, yeah.
It's like they're
Uh,
just now starting to make robots where they brag can do simple tasks like that, like folding laundry, let's say.
Yeah, I mean, it had this specific set of things that it could that like this specific set of tasks that it could do, but
Right,
like what
right.
was amazing is you could communicate to it in human language, and it could do these things, and it
Huh.
could pull off these complicated tasks, and it was an incredible demo that inspired many, many people. But it was written in this language called Microplanner, which is an actor model system,
Hmm.
and um, was a simplification of the more complicated one, Planner. And Carl was making a lot of claims, and so Jerry Sussman and Guile Steele were like, well, let's try to actually understand this. So they decided to do an implementation of it. And I think Sussman was teaching a class on the lambda calculus at the time, or at least taking one. Um, and uh, and they were in the middle of implementing things, and they ended up realizing, oh my God, these are almost the same thing. And it led to an understanding of this idea called continuations, or at
Mm.
least first class continuations
Hmm.
in programming languages, where in the actor model thing, there's a question of, how would you have when you call a function, right? Let's say you wanted to add two, you wanted to add two numbers together and you want to get the result, right?
Mhm.
You have this add function and then you give it, like 3 and then 5 and it gives you back 8, right? So in
Mhm.
actors, what you would do is that you would give it 3 and 5 and the address for an actor that you get the response to, which was called a customer.
Huh.
Well, when trying to figure out all this stuff, and they were writing with an event loop,
Mhm.
um, they ended up realizing that, wait a minute, this thing that you return things to is actually the same as this idea, as the functions that return things. It's just that the functions that are returning things are kind of doing so implicitly. So they
Mhm.
had this thing that was called continuation passing style. They wrote their compilers to do this thing that was actually converting to that would actually be as if you had A and then B and then you pass it to C. It led to this and these it led to these powerful time traveling, interesting programming things. But the big conclusion that Sussman and Steele come away with is that these are mostly the same thing. Actor model and lambda calculus are mostly the same thing.
Hmm.
Now, they actually kind of say it's not exactly the same thing, but it's mostly the same thing.
Mhm.
But it's close enough to the same thing. From a calculus perspective, the compiler is really doing the same thing, basically.
Mhm.
And the program flow is the same thing.
Mhm.
Now, Carl got really frustrated and was like, no, 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 it's not the same thing. They're, a scheme to kill actors. It's like, and he would be really frustrated about it.
Mhm.
But what's interesting is that in the days of programming, you had Mark Miller and Dean Tribble and everybody from kind of the Xanadu and then the I'm trying to think
Elec-
of what the name of the
Electric
lab
communities or
was.
the market what was the
Well, there was
information market?
Agoric
Amex?
and there was Agoric and there was but I'm actually specifically thinking about the Xerox PARC team.
Oh,
They had a team called working on a programming language called Joule, which is what Dean
right.
Tribble, who's the CEO of Agoric, actually was the main lead on,
Mhm.
and it was faithfully following the actor model, which is all you can do is send a message. And one of the big disagreements there is does it matter if things are synchronous or asynchronous? And they took
Mm.
the everything must be asynchronous approach because they discovered all the challenges that happen when you end up having when you try to do networked programming with synchronous objects and the way that they lock up and everything like that.
Mhm.
So they took the actor all you can do is to send a message thing. So
Mm.
what ends up happening is that the VAT model gets discovered kind of by accident as a joint, but a real union between the lambda calculus perspective, or I mean, the lambda calculus arguably might not care about order, but let's say the sequential execution variant
Mhm.
of the lambda calculus, which is what most people think about, right? So the
Mhm.
sequential execution lambda calculus and then the actor model because it may be that the lambda calculus, if you're free of side effects, doesn't care how you execute things in what
Right.
order, but that's an aside. Um, or if a sequential version of programming that's kind of lambda e, and then the actor model, they accidentally created a real union between those. And the way that it happened was that Electric Communities was set to this programming language called Joule, was then being worked on by Agoric, non-plural, the kind of predecessor to
You
Agorics.
mean
Um,
Agorics? No, it's the
yeah,
other way.
sorry, Agorics, the predecessor to Agoric. That's
Yeah.
right. And there was a contract dispute between Electric Communities and Agorics,
Hmm.
and and so electric communities didn't get access to Joule. It was between the upper management,
Mm.
between those two. So suddenly there was a panic and they had to figure out what to do. Uh, and Mark Miller told me that, they gave me the name. I have an upcoming podcast episode that I still need to finish editing to release of Foss and Crafts that has
Hmm.
Mark talking about all this history. But
Oh.
but the but they ended up releasing a what happened is one of the developers basically locked themselves in the room for 2 weeks and ended up programming a a, a replacement for Joule called E that was kind of a hacky thing written on top of Java, and then later turned into a more serious version of things that Mark Miller took over the development of. But
Oh.
one of the things that was discovered about it was originally porting Joule, but since Java had all these sequential call return things and they wanted to use them, because in the interest of time,
Huh.
they
They just hacked it in.
allowed you to call these sequential Java things. And then that discovered the VAT model of computation, that you could actually, and the VAT model of computation has the following observation. In the actor model, it doesn't matter where things live. Any actor can send a message to anywhere else, and you actually don't even have a conception of an actor living on a event loop. Maybe there aren't even event loops. Maybe actors are actual real living people walking around. You don't know. It
Mhm.
doesn't matter. It's up to that actor to decide how they behave. Um, but in the VAT model, you take more seriously the idea of these event loops that the things are running on top of, and you say, okay, actually, these are really important. These are actually communicating with each other. And the reason why it's important is that we are able to have sequential call return, which can be really useful sometimes to say, do this thing and then do that thing, etc. Um, and the what you end up doing with that is you can have sequential execution, but only between objects in the same VAT. Objects
Mhm.
talking asynchronously can communicate with any object anywhere they have a reference to.
Right.
Um, but objects communicating sequentially can only communicate on what if they are what's called near to each other. Are they in the same event loop? Are they in the same VAT?
Mhm.
And this turns out to open up a bunch of really easy solutions to things that were tricky previously, like how do you exchange money without leading to possible corruption as you increase the value of one part of, like, somebody increase somebody's bank account and then decrease the other one, and you, if there's a failure that happens, you want to roll that back, right?
Mhm.
um, you want to do it all or nothing. um, and um, and so it was discovered that the VAT model actually solved that and improved the situation with many other things. Um, as a side note, Jessica Talon, when she came on to Spritely, actually came up with an interesting variant of how to do the bank problem, the mint problem, actually completely asynchronously. But that's
Mhm.
a separate thing.
Yeah, I remember you
But
telling me that.
yeah, but what Spritely made a contribution in a certain sense in that Spritely took, so the VAT model was actually the union between asynchronous programming and synchronous programming, right? Kind of brings the synchronous Lambda world together and then the asynchronous actor model world together under a unified vision with these communicating event loops.
Mhm.
And then what Spritely's big contribution with Spritely Goblins is a transactionality. It's it's that when an error happens between these different things, that you can roll it back automatically. Actually, when I wrote the initial versions of Goblins, I hadn't actually ever run E. I just assumed that Mark had added transactionality. So I was like, oh, how do I add this to the system? I've been playing around with some functional game engines. Here's how I think I would do it. And then later on, I found out that actually E never had it.
Mm.
And so that was actually Goblins' big contribution, was the transactionality on what are called turns, a top level
Right.
message coming into an
Wait, so
event
are
loop.
you saying you've got distributed transactionality, as in if you threw an error, like, I mean, obviously my machine would have to agree to, but can we like unwind the game together? Um,
So you have transactionality only happens within a single VAT, but you
right,
can still do what you were saying.
right.
Let me explain why.
Yeah, we'd have to
So
kind of build that into it, right? It would almost be like the the checkpointing system would be part of the distributed
You
capability of
would
something.
you would build a abstract shared VAT,
Right, right,
an abstracted shared VAT. So the
right. And now
network
we're kind of
address
getting to that, like we're starting to invent a consensus algorithm, right?
we're
Like,
starting to invent at least a quorum system that
yeah,
requires some degree of consensus on the messages. Yeah.
yeah.
But um, yeah, you can end up with a quorum of execution as long as that is deterministic, as long as everybody agrees on the messages incoming, then you can have transactions. Specifically, we don't usually use the transactions for distributed stuff. Specifically, it's really just that, I mean, it's used for distributed cooperation,
Mhm.
but not in that multiple parties will roll back automatically at the same time.
Right, right.
I mean, you can build that in the way that we talked about on top of there, but the way that it's usually used is actually that when you have a uh, when you send a message to somebody and something goes wrong, you want to not have unintended corruption in the state of your actors, right?
Mhm.
Of your objects in the vat, right? You want them to automatically roll back to the state before they got that message. You want to inform the person, hey,
Mm.
you did something that caused an error in my system. Sorry, the promise is broken now. It doesn't work. Didn't work out. Sorry about that. But you actually want it to roll back to the previous state
Mm.
automatically,
Right.
right? So it's just basically it's as if that never happened, except that you inform the promise related to the message that sent it that it's broken. So that's the way in which we use transactionality, and
Yeah.
we found that that improves a lot of things because there's a whole class of error handling we don't have to do. Like a lot of types of cleanup just happen, right?
Mhm.
So
Yeah, and that's like that kind of concept is is completely natural to anyone in the Ethereum ecosystem, like because that virtual machine has a gas metering system. So the idea of running out of computation rights and then having everything roll back is like
mhm.
it's fundamental to how the machine is able to be public. And so that kind of hints at how Sprightly can expose things like more privileged computation to, maybe not strangers, maybe strangers, maybe people you don't even trust at all, potentially metering their computation or limiting what they can do in some way and making your machine resilient to their behavior because you're able to roll back to some degree. Um, my understanding, I need to get more up to speed about this, but the approaches that the Agoric team has taken to creating the distributed object model in JavaScript has had trouble, I think, right around that area. Like the JavaScript runtime and the swing set that they're building, doesn't really have trivial transactionality built into it. Like um, their main blockchain is building on top of the XS engine, and so they're using the snapshotting of this underlying JavaScript engine. So tearing it down and spinning a state back up is actually a fairly heavyweight process. So it's like it's not that it's impossible, but it's a bigger penalty when somebody throws you into an error state, and how you then restore from it. Um,
It's a bigger problem, as you're right that in Agoric's case they have an answer on their blockchain, which is that they have that they have control. They're using a JavaScript runtime that has support for the specific thing built into it of the ability to roll back. It would be a bigger problem if you were in a browser, right? In a browser, you
right.
don't have support of the underlying language runtime. Browsers don't currently, at least, expose the ability to do language snapshotting. And part of the appeal, of course, of JavaScript is that you want code that can run in many different contexts, especially browsers. So it's a challenge in
Yeah.
that model. They do have a
It is possible. I've done it. Like what you can do is you can make a compartment where you are playing messages into it. And then if it ever gets into an error state, you throw that one away and you make a new compartment by replaying all the messages to it.
but
Um,
that can result in ON squared behavior,
yeah,
because
yes.
if you imagine having five messages and then three of them error in a row, right? You're having to replay all the messages
Oh, we'll definitely
for
throw away any messages that caused failures.
yeah,
But
yeah.
yes.
Okay, all
But
right.
yes,
Let's
it's
say
expensive. Yeah.
50 messages, the last 10 of which have errors, right? For each one of those each one of those last 10
Sure.
ones, you're
Yeah,
having to
you're
play the
replaying
previous
ON.
40
Yeah.
again.
It's
And that
ON to the power of how many failures you encounter. Like,
yeah. So
yeah,
it's unfortunately it doesn't work with it but like I mean it's also like this is the approach that Sprightly Goblins is taking is I mean, it's a different design choice from the outset because we're not using, like, if you wanted to set a variable, you don't use schemes, like assignment operator. We have you actually, invoke this cell and change,
mm,
like, you have to use our operators, right?
right.
So one advantage that the Agoric folks have and their particular thing is that they're able to use things like assignment and stuff like that using the operators that come by default in JavaScript, right? And so that allows for a certain amount of programming intuition of what comes with the underlying runtime environment, right? I think in Goblins you basically have to accept the Goblins philosophy, which isn't so bad.
Yeah.
We
Yeah,
certainly find it.
I'll tell you, like I no, the Endo machine isn't like fully live and available to play with yet, but I have done a lot of thinking about what it will be like to build on it. And I do think that one of the appeals of building in an environment like this is the ability to share the variables and the functions. So while you may have the advantage of being able to use local assignment, for things that you just use local assignment on, you don't have the benefit of casually sharing it. Like how do I give you a read key or the ability to set it or mutate it or like all the interesting things that you could do around it. So my guess is the cell that you're building for your data types is actually going to be a type of plumbing that most developers end up building around all of their important data anyways, even in an agoric environment, because the shareability is actually like central to the appeal.
Yeah, that's why since they're Goblins objects, it means that just like any other object in Goblins, you can pass them around.
Right.
So and actually, I mentioned that there are three things that actors can do. So I'm gonna actually give a key insight into how Goblins works here,
Mm,
right? So the three core operations within the actor model um, of computation directly apply for how our transactions work. So here is the big abstraction that Goblins brings to the table. We don't just have the VAT event loop. We also have a data structure underneath it called the actor map. Terminal phase was written before we had working VATs, actually
mm,
just using low-level operations on top of the actor map.
mm,
You can use it with VATs, like it could be rewritten to use that, like the VAT machine we have now, but it was written before then. And it's not necessary to be able to build a game like Terminal Phase.
mm,
So you have what basically from using this data structure of the actor map, you have an indirection that is between the reference for the actor and then its actual current behavior, right? So you can
mm,
think of an actor as being a mapping between the reference that allows you to address it
mm,
and the behavior that it will have in response to the next message.
mm,
That's the actor, right? And
mm.
it has
It's the
within
combination of those things.
yeah, and within that behavior, it's a closure, right? So it captures things like what actors it knows about, right?
Mm,
Whatever other information is relevant to it, right?
mm,
So when a message comes in, it's literally just a lambda, it's just a procedure.
mm,
So it's just a mapping between that reference and that procedure. It's literally a hash map under the hood.
mm,
With just a little bit of extra bits around it for accounting. When you send a message to this actor, it says, okay, let me look up what my current behavior is and apply all the arguments in the message to that actor. And then when the actor is running, it says, okay, I want to create another actor. Well, what happens is that there's multiple kinds. There's actually an interface for these actor maps. The most common one we call a WACTor map, and it's because it's a
mm.
weak hash table actor map. It's just a hash
Oh,
table that's weak keyed, so that you can when it can be garbage collected when actors are
right.
no longer needed,
Yeah.
they're garbage collected, right?
Yeah. Makes sense.
So it's a mutable data structure that can be garbage collected. But when you're actually in the middle of a turn, right, in VAT parlance, when you're handling a message, it actually creates a transactor map, which sits right on top. And a transactor map references its parent. And you can actually have a transactor map which references a transactor map which runs through the transactor map if you want, but usually it's just one. So you have a transactor map that's pointing at the Wactor map, and what this is doing is it's actually storing, let's say an actor creates a new actor. So it
Mm-hmm.
creates a new actor, it spawns it. And then that spawned actor, it gets a reference.
Mm-hmm.
It gets the reference back for the thing that it spawned, and that actor that was created, the constructors in goblins are simply procedures which create procedures. So the outer procedure is the constructor, and the
Mm-hmm.
inner procedure is the first behavior it will have.
Okay.
So it constructs its first behavior, and that's mapped onto the transactor map of, here, let's say Alice creates Bob. So Alice creates Bob. Bob is not in the underlying Wactor map yet.
Mm-hmm.
Bob is now a union of, is a mapping between this new Bob reference
Mm-hmm.
and
And that initial
Bob's
constructed
initial
object
behavior.
is
That's
initial
right.
behavior.
And then now let's say that Alice, the next thing that Alice decides to do is, actually, I'm going to send a message to my buddy Carol. So Alice sends a message to her buddy Carol.
Right. Mm-hmm.
Well, during the turn, this is collected into a list of messages that we want to send at the end of the transaction.
Right.
We don't send it immediately. It's if the transaction succeeds, we'll send it.
Mm-hmm.
And then the next thing that Alice does is says, you know what? And now that I've done this, I want to actually change my behavior for the next time I'm called. Maybe I want to
Mm-hmm.
increment a counter. Maybe I want to
Mm-hmm.
do whatever, right? So Alice actually does a become. I want to become this new behavior.
Mm-hmm.
So Alice becomes this new procedure representing her new behavior. And and what we actually do is we take the underlying Wactor map has Alice mapped to her old behavior, but in the transactor map, we map Alice to her new behavior. So if then Bob ends up invoking Alice within the same transaction, Bob will invoke Alice within her new behavior, even though it has not yet been committed. Now the turn completes, right? And let's say there were no errors. Then what happens is we commit every
All the changes.
object to the underlying one. We just iterate through it and commit everything. If something goes badly, we just throw it away. We don't need that
Mm-hmm.
anymore. We don't need
Right.
the
So
transactor map. We
the
don't need the new
transactor
messaging.
map is kind of like the intermediate, tentative, non-committed set of state that results from the current turn of the
That's
machine.
right. And this turned out to have a really cool property we didn't anticipate. Um, so I mentioned that we have our persistence system.
Mm-hmm.
Our persistence system is really efficient. And the reason it's really efficient is that we don't have to walk the whole object graph to see which objects have changed. Because we can look at the transactor map and say, hey, which objects changed
Right,
inside of the
because
transactor map?
it is a diff basically,
Yeah,
right?
it's a diff. So you can actually persist only the objects which have changed. And
Oh,
you can,
so I was already imagining that it was a pretty efficient serialization scheme, but it's not just efficient like in total size. It's efficient to append to,
yeah,
for example.
yeah,
Nice.
that's right. And it's efficient in time and space. Yeah.
Wow.
So, so the serialization to disk system, the persistent system, is actually itself able to benefit from this
Wow.
transaction system too.
Wow. What a cool, don't you love it when like these side benefits drop out as if it was like the goal of the platform? Like you could imagine somebody like working really hard to make like an optimal diffing file serialization format, and then reinventing the actor model or something along the way.
Right.
Sometimes these models they're so they feel like kind of like you're dealing with some fundamental stuff and like so great benefits drop out, and that's a really cool example of one.
Yeah, the power of composition, right? When it turns
Yeah,
out that the composable systems that you have like actually result in the right emergent properties to be able to solve the problem, right?
neat.
So yeah, I was really pleased with that, and Jessica did an amazing job So we call our persistence system Ori, and that's like an internal name. We don't, I mean, we put it in the blog post, but if you read the Goblins manual, it just says our persistence system, right? But we've got, it's also, if you read the blog post, we have this cute little fire character that turns itself into a
Yeah,
crystal.
yeah, yeah, yeah.
Um,
Your animations are a signature of the brand.
yeah, and so the the that whole persistent system, um, I I had actually prototyped it after reading Mark Miller's safe serialization under mutual suspicion paper, and I gave it to Jessica to implement, and Jessica ported it from the initial Racket version over to Goblins to Guile, but it wasn't just a port. That was just the start of it. Because one of the big problems is that the initial version was really painful to use.
Hmm.
It worked pretty well, but it was like really difficult. The new version is like the new version is the different. For example, to take a cell,
Hmm.
um, a cell is only, I think it's like 4 lines of code to be able to add the transactional cell. Maybe it's 5 in Goblins, but all you have to do to make it a persistible cell in the system is switch it from define and then the cell constructor to define dash actor and then the cell constructor, and the system does all that automatically. Um, Jessica put a ton of thought into it. She added the diffing mechanism. She added all this stuff. So like really like a lot of these ideas end up like changing hands a bunch. So um, Mark can be attributed for a lot of it. Also, my co-founder Randy Farmer apparently had a early conversation with Mark where Mark originally thought that orthogonal persistence, which is that language style snapshotting, would be necessary in the electric community these days, and Randy convinced him that object knows itself what it needs to serialize.
Hmm.
And then Jonathan Rees who wrote a paper called "The Security Kernel Based on the Lambda Calculus," which
Hmm.
is one of the things that led to Spritely. So you could think of Spritely Goblins as being kind of a combination of Jonathan Rees's paper, a security kernel based on the Lambda Calculus, and then Mark Miller's design and company, of course, for both of these people. But Mark Miller's all of his essays on E and as a programming language and kind of synthesizing those ideas, and
Yeah,
then me playing around with functional game engines and stuff like that.
yeah.
Um,
Yeah, and
but
in case anybody's listening, like you summarized that relationship really well in the Heart of Sprightly paper, and
right, right,
that's what got me to read Jonathan Rees's stuff. I kind of got here through some of Mark's work, but yeah, Jonathan Rees and getting exposed to how lambda calculus relates and just kind of matches all of those models worked really well. So are we due to compare the actor model to the object capability model now? It
oh,
feels like we're getting really close to
we
that.
sort of did, but I wanted to finish. But
Did
let me. I might not have been clear
okay.
enough. So
Sure,
let
sure.
me. So the one more thing, which is that
Sure.
Jonathan Rees made a comment to Mark, which was the that Jonathan Rees said to Mark that serialization is basically eval and apply in reverse, uneval and unapply. Now the
Hmm.
key thing here, now that's throwing in some new terms. I know this chat has been full of terms. If you're a fresh listener to this thing and
Mm-hmm.
you've never heard this, their new terms are probably flying by about 1,000,000 miles a minute. But the eval and apply, you've probably seen them in some programming language, right? Like if you use many programming languages, they sometimes have eval, and people tell you don't use that; it's really scary, right?
Mm-hmm.
But it lets you run code that and apply lets you take some sort of function and say, actually, I have this list of arguments as a data structure. I want to run it with this list of things,
Mm-hmm.
right? Um, and if you read Structure and Interpretation of Computer Programs, a famous computer science book,
Mm-hmm.
they say, like, well, at the heart of computing is eval and apply, and they show it in kind of this yin
Yeah.
yang
Yeah.
mechanism, yeah, where like each one is calling the other, and it's kind of got this dualism of
Hmm.
evaluation. So the big observation that Jonathan Rees made, which is we follow very strongly in Ori, and therefore Goblins' pure serialization mechanism, is that serialization is uneval and unapply. It's eval and apply in reverse. What you're doing is you're taking the program and you're actually kind of like doing the destructuring of it by running it backwards in a weird way. And it serializes to a graph with a starting point, an entry point, and so the and then and rehydrating everything, like restoring everything, is actually running a special eval apply metacircular evaluator to bring everything back. So this explaining why that is, I've already done a bunch of deep dives on a bunch of things. I'm not going to back up my claim that
Okay.
serialization is uneval and unapply,
Yeah,
but
that's a fun piece of candy for the interested viewer to enjoy at a later time. Um,
right. But to answer your question, how does I guess actually you did ask a question that we didn't answer yet, which is how do object capabilities relate to the lambda calculus and the actor model, right?
oh, oh, I mean, I think I see how. Well, it's funny because you explained how Sussman and I forgot the other Steele
Steel.
concluded that lambda and actor was almost the same thing, and I have a pretty good sense of how I see lambda and OCAP as the same thing. Um, and yet I see a difference between the OCAP side and the actor side. And I don't know if it's almost like a convenience layer, maybe, is how maybe I describe the OCAP. Uh
What would your difference be that you perceive?
so when I think of the actor model, you're sending messages, right? Like they're like envelopes, let's say. Um, and it's just data. So if I give you a bunch of data, now some of that data could be the address of another thing, right? So then that gives you access to it. In which case it's getting very capability like because you can pass around addresses and arguably maybe a function is an actor. And if you model it that way, then I guess it's pretty much the same. But
Especially if
still
you
it's
encapsulate the addresses so that you can't read them, which is of course what we do in higher level
right,
languages. We don't
right.
share
Yeah,
the
yeah.
pointer address.
That's a good articulation of what I feel like I'm trying to get at is like you shouldn't see the address or like as
Right.
like a prop. So
The term address is a bit of an illusion because it makes us think too much a little bit about like somebody's physical address possibly. But
mhm,
if you think about address in terms of um, if you're running JavaScript, right?
mhm,
You also each function has an address.
mhm.
It's actually there's a pointer to an area in memory which it has the function,
Right,
but
right,
JavaScript is not letting you do pointer arithmetic on it, right? Some
right.
C or C++ developer has access
And
to
that's
that thing and they
important.
can look at the
Yeah,
address.
yeah. And
Yeah,
that's
and
what
it
gives
turns
it
out to be
memory safety, right?
it's critical for memory safety and it's critical for object capability security
Yeah.
safety. So this is
And
something
if I could just enumerate addresses, like I could brute force the phone book, then I could be a scammer. And so yeah, there's like a couple properties, I guess, that and maybe it's a subtle difference, but yeah, the unforgeability of these references and the fact that the references themselves are maybe opaque and so you just get the reference. You don't, it's not a data structure you can operate on, it's just a thing you can send messages into or something.
and
Um,
that is if you talked to Carl Hewitt about it, Carl would say, that like an actor address is not it's not a string, it's not whatever.
oh.
It's like,
Oh,
so
really?
like yeah. So I mean it could be, but you should conceptually think of it. So it really is conceptually like a reference to something that you don't actually have. So it really
Which
is like
makes
a
it a lot like a
function.
lambda. Yeah.
Makes it a lot like a lambda, and it makes it a lot like a distributed object, right?
Right.
So the
Yeah.
reason that the VAT people don't call their stuff actors all the time, and I do, and by the VAT people here, I mean talking with Mark Miller and Dean Tribble specifically,
Kind of a word. Yeah.
um, who is because they're trying to honor Carl Hewitt's frustration with the with there being a distinction between because he was very insistent that there's a distinction. There is a distinction in the actor model. You can't do synchronous operations. Can't
Mm. Hmm.
The big distinguishing part between the actor model and the synchronous model of execution is between synchronous messages and asynchronous messages. And the big distinguishing feature there is that you get a different benefit from both sides of it. From sequential messages, you're able to have control over the ordering of events to some degree.
Hmm.
With asynchronous messages, you lose a lot of control over the ordering of events. You know, you could pipeline things and stuff like that, but you
Hmm.
really don't know when this message is going to be received or processed between this message in terms of the larger ordering of the system, right? And so you lose some determinism in a realistic network graph, right?
Hmm.
But you get the ability to have kind of global cooperation in a way that's safe, right? You know,
Yeah.
if you try to do synchronous cooperation, you end up in the world of deadlocks, right?
Hmm.
And hell, right? You know, so like, um, and this is the thing that many programming languages got wrong. Sorry to any Go fans out there, but Go got it wrong. They read Tony Hoare's, you know, like Go implements communicating sequential processes, which is a fine foundation to start building on top of things, but is actually insufficient if you're worried about large scale cooperation. So, for example, we implement goblins on top of a communicating sequential processes layer. We implement our actors on top of CSP. But it's very possible when you have the communicating sequential processes model, to throw in a completely different computer science idea, is where you have these different processes, but they rendezvous. Like they have these different channels over which they're going to exchange messages,
Hmm.
and they both stop. Like this one
Oh.
stops to send a message, and then this one stops to send a message, and then they pass the message off, and then they both go on their way. And
Oh,
this
huh.
is how Go works. It's how most of these things work. Um, but the really now they Go uses coroutines to try to make it a little bit easier,
Hmm.
but it's still communicating sequential processes, and there's
Or the
it's very
coroutines, is that maybe like a third actor that's going to be pausing with each one instead so that they don't have to synchronously pause or something?
it's really to kind of make things look a lot easier in terms of making it look more sequential.
Oh,
It's
okay.
let's leave that on pause. Let's just talk about
Yeah.
CSP.
Yep.
So the difference between the way you can think about these different models of execution in asynchronous environments, one of them you can think of as being like, um, imagine you're in a classic cubicled office environment, right?
Hmm.
And you want to send a message to somebody, or you want to tell somebody something. You can do a couple of things. One of them is you could send them an email, or you can show up at their desk, right? And
Hmm.
there's a nice part about showing up at their desk is that you can have this nice back and forth conversation that's like, you know, like people sometimes value in-person communication,
Hmm.
but sometimes people are like, oh, this could have been an email, right? You know,
Right.
um but the bigger problem is, imagine if Alice decides, oh, I really need to talk to Bob. And Bob and Alice goes over to Bob's desk, and Alice talks to Bob, and it's fine, right?
Hmm.
Now imagine if Alice says, I really need to talk to Bob, but Bob
But he's not there,
sh-
and she waits
he's not
forever.
there. And meanwhile, he's over talking to Carol, waiting for
Oh,
Carol,
oh, and Carol's waiting for her.
and
Ah,
Carol's waiting for Alice, and all three of them are just sitting there frozen, right? In fact, it
hmm.
can even happen with just two of them. You know,
Right.
if you've got a distinguishing thing between the inbox and the outbox, effectively.
Right.
But the
I
uh,
see.
yeah, so this is, it's so easy to end up in deadlocks with communicating sequential processes. So like I don't consider that to be a sufficient asynchronous programming mechanism for developers to be working in. And in fact, the place where Jessica is Jessica's such an incredible we she recently we canonicalized her title as a founding technologist to recognize how she's been here since the beginning of everything. And we've informally canonicalized her title as an internal title of the Goblin Enchantress, or Enchantress of the Goblin Realm, I should say. And that's partly because Jessica was the first um, Goblin's first programmer out there, right? The
Hmm.
first person who experienced programming starting with Goblins, and
Whoa.
really, really ran with it. because
Wait,
like
wait,
me,
you're not saying she learned to program with goblins. You're saying that she's the first person who learned to program in the goblins
with
environment.
in a
Uh,
goblin's environment, thinking in a goblin's way. She already
right.
knew how to program,
Yeah.
but with Jessica's, like, there will be a lot of times where we'll be working on things and I'm like, oh, just do it this way, and Jessica's like, that's not goblinsy enough, and I'm like,
Uh-huh.
how dare you, right? I'm
Ha ha
like I
ha.
designed a lot of this
Oh
stuff,
wow.
right?
Look at
But she's
that.
right,
She's got the
and
intuitions, huh?
she says, no, 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 you're a scheme programmer who built
Mm.
goblins. I'm a goblins programmer who's immersed in scheme, right? Like I
Wow.
started with goblins and like, which happens to be embedded in the scheme environment, but I think as a goblins programmer. And
Nice.
so,
That's what I hope to be, by the way. I want to I'm probably gonna skip the scheme and go straight into be a goblin's first lisper, basically. Um,
well, you did some, you were working your way through SICP to some degree,
yeah,
and then
yeah,
and
yeah.
then
So
uh,
yes, so I got like a rudimentary versing in it, but like I feel like if I never got to the point where it was what I was reaching for to do anything, so I feel like I
right.
kind of like fell off the cliff.
But well, so this is now let's loop this all back because we've talked about
Sure.
goblins, we've talked about Hoot, and earlier I talked about Julie's breakthrough thing today, where Julie got core.scm of goblins, like the core version of goblins, the transactional model, right? Like, which hopefully is more understandable about what we meant now by this point, that we have the transactional version of goblins working enough to build terminal phase, right? Enough to build that time traveling programming environment, right?
Mhm.
Um, the uh, what's really exciting is, and the rest of it I expect to come pretty shortly. What's really exciting is that now that we're getting things in browsers, traditionally it's been very difficult to get a lot of the stuff up and running, in that you had to be kind of an expert in some of these particular tools. Like you probably had to run Geeks on a Linux machine, and
Mhm. Yeah.
you had to run Emacs if you wanted to code in it,
Hmm.
and all these types of things. Well, what's exciting about having goblins on Hoot is that we'll be able to start showing a lot of this stuff off directly in the browser.
Yeah.
One of the things I also hope that we'll do, and we need to, I'm currently scheming to try to figure out how to make it happen. But I would like to get to the point where actually even we have a in-browser programming environment where you can
Yeah.
actually program
You
goblins
should.
without having
It,
to open Emacs, let's say.
I don't know. I know that you're aware of LURK, the Lambda, the ultimate recursive knowledge. They launched an in-browser like tutorial system. So you can
Nice.
write their Lisp in the browser and then it generates the zero knowledge proofs for the little program you just wrote.
Oh, that's
So
great.
yeah, and but the way that they figured out the zero knowledge thing is, it's recursive. So every S expression compresses to a proof of a fixed size. So regardless of how big your program is, it produces a proof of a fixed size where you can always say this code with these inputs produced this output, and you can prove it in fixed time. Um,
Nice. That's
yeah,
amazing.
it feels like there's got to be some opportunity for like when we're talking about like sometimes you want to escalate something up to a different level of safety. um I have to imagine there would be some way to like have that function available, and then sometimes there's a category of things where you want to prove you got a result, and like they were saying, they kept finding novel applications for it, like using it as like a type validation or something. Like you could pass somebody proof that your input is passes all their validity checks, and then you could save them server time or things like that.
Hmm.
Um,
Hmm. Yeah,
but
that's great.
yeah,
I mean, maybe there's ways to combine that with like the lockstep stuff that we had talked about earlier. Like, maybe you get a
yeah.
hash from somebody and you already know they played a valid move in the game. You don't have to know what it
Ah,
is, you
hmm.
know?
Oh, right. They could give you a proof that right. So they it's easy for them to say, oh, you could prove that their move followed all the rules. Like
Right.
for example,
That's right. And so you could in because one of the things that you might do is that you might both commit to a rule is something, and then somebody might reveal that they played an illegal move, and then you're stuck with the conundrum of, well,
right.
do we reverse that or do we consider it game over? right? And it might
Yeah.
be you, and the safe thing to do is to just consider a game over at that point
Yeah.
and consider them to have lost. But it would be nicer if you could actually just say, sorry, that's actually, the referee is like, like analyzes it and is like, oh, actually that wasn't valid. But it's a turn-based game, so you can fix it, right? Um,
Hmm.
so that's an interesting thing. I mean,
Yeah.
I haven't. It would be curious to see an application of that. Zero knowledge proofs
Oh.
are interesting. I've never given them the amount of time that I would like to, but I was tempted to implement the LURK. Like they had a meta circular version of LURK that they had
Hmm.
written at one point, and I had
Neat.
thought about trying to do a port of that, but I never got around to it.
Here's a sprightly question. I feel like we're kind of naturally starting to wind down, but here was something I was playing with in my head, and I don't know if that's a tool for it, but you've probably thought about it. Like, so let's say I make a blog in Sprightly, right? So V1, I've created it. It's an object on my machine. So every visitor is coming to my machine and they're hitting, now I know you've talked about like the amphitheater model, for example. So like, okay, maybe what I need now is I need some actor out there that's really good at propagating my messages. And so most people go to that. It's kind of like a pub, right?
Kind of
Um,
like pub up, yeah, yeah, yeah.
right. Now, but what if what if I shared with you the right to add posts to the blog and then I go offline,
Right.
right? So
Yeah.
so it would be cool if you could prove, let's say to the pub that you had permission to do this thing, right? Even if the host isn't online. And obviously there's a question about determinism. And so if you need to order the messages, it may be that you always need a consensus or some kind of quorum to say like, yes, you did the next blog post or something. But with
Well,
transactionality, maybe you could basically say, yes, I this is the latest post per this proof. You don't even need to know the policy. It could be a zero knowledge proof.
well,
And yeah.
there are multiple ways you might tackle this, and you're right that this is a if you're designing this on top of kind of let's call them live actors, you result in this thing where if something goes offline, then it's offline for the moment, right? If
Mhm.
my website goes offline, and if I had a comment system, I don't currently, but like then nobody would be able to comment on it while it was offline, right?
Mhm.
Um, the but the there are multiple solutions you could take. In the case of that, pushing something to that pub where they know that you could publish it. One thing that you could do is you could actually use a certificate-based capability approach, right? Like so, ZCAP
Mhm.
LD
Right.
and UCAN are two examples of this,
Mhm.
right? And those that's one way you do it, where you hand the certificate that says I can prove that um, from the root of authority of this object itself, it delegated it to Dan, who delegated it to me, and so now I'm doing my invocation, and you can just walk the chain, and that, and it doesn't require any blockchain to be involved. It doesn't require anything else.
Mhm.
I mean, revocation does become an interesting challenge with
Right. It's
certificate-based
just it's
capabilities,
kind of race to the authority.
right?
Right.
But
Um,
but but moving that aside,
yeah, yeah,
otherwise,
because I do think that coming from the Sprightly CEO, that that that's a cop out because that, while totally satisfies the design constraint, is clumsy to work with, right? It's not fun to program in that way, right?
programming certificates manually is like it's like writing assembly language or C or something like that, and we want
Mm,
something a more high level, right? That's what
yeah.
goblins is meant. One of the reasons that got, well, I mean, the reason that goblins exists, right? The reason that
Yeah,
all of
and
this
I'll
sprightly stuff.
note, by the way, that delegatable is a framework that I made for certificate-based delegation in
Oh,
Ethereum.
nice.
So for people who are following that work of mine, like I'm kind of throwing a little shade at it, but like partly as a way to kind of hint at there are better abstractions we can build on top of things like that.
Right. Like for example, Okapan is a powerful thing, and you could run it by hand, right? Like you could like little do all
Right,
those bits of the stuff, but it's designed so that you never have to, right? Like it's designed to be cooperative with a programming language, so that programmers are feel like they are doing the ordinary programming they're doing. They're not doing bit fiddling of data, right?
right.
They're doing invocation of functions and talking to objects and stuff like that, the way they're used to. The another approach you could take, you could take a zero knowledge proof approach, and another approach you could take. I had another one, but I might be blanking on things
Yeah.
at this
So you
point.
could
I
make a
might
little
be
quorum. You could pass around a zero knowledge proof. You could do a certificate chain.
mm,
Um, you could do a pub
yeah.
of some sort.
The other one I was going to bring up. I mean, you could say it's a little bit certificate chain like under the hood, but it's a
Mm,
generalized one specifically for file system type things.
mm.
You could take the Tahoe LAFS approach, right, where you have these specific. Have you ever looked at Tahoe LAFS? I mean, you certainly
Not
know
not
of
deeply
it.
enough. I know I'm such a fan of everybody who worked on it, and I know
Yeah,
it's a
you know
capability
Brian and
system.
Zuko and everybody,
Yeah,
but
yeah,
the
but I actually haven't dug deeply into what its contributions were.
well, it's interesting. I mean, it's it's interesting how much it did right very early on. It's like IPFS in that it's content addressed and distributed and stuff like that.
Mhm,
Um, uh, but one of the things that is interesting about it is that it's also all encrypted, right? So like,
mhm,
um, the people hosting the content don't necessarily know what they're hosting. So
mm,
the big challenge with IPFS stuff, right? Like you have some risk of hosting stuff. You might want to help the network, but you might actually be at legal risk for trying to help the network.
mhm,
Sometimes it's better to know less,
mhm,
um, so the approach that Tahoe took is that like, well, we're gonna chop up all the things. So like if we don't know, because there's size of file attacks, you can imagine if there was a very popular movie ISO that's being shared around, you get if somebody shares exactly that number of bytes, you could be like, well, I know what you just shared. You just shared this movie, right?
yeah,
Um, so they chop it up into fixed sized chunks and they encrypt everything. And instead of just handing you um, and so there's the and instead of just handing you the hash of the initial node, so you can imagine you get the initial node, which then allows you to unlock the next nodes, which allows you to unlock the next nodes, and you grab all the content addressed objects and pull them down. Instead of just handing you the content addressed object of the first chunk, um, um, it hands you a tuple of the content address and the key. So that's a read capability. If I want you to be able to read this thing, I hand you both of those things at
right.
once. So that's how you handle a read-only file. And
Yep.
then they have a write system, which actually works an awful lot like capability certificates. It's basically like a
Mm,
certificate where the name of the file for the mutable file is basically the initial key.
mm,
And then it signs off on a certificate saying, here's the new version of the object.
mm,
And so somebody says, oh, I want the latest version of the object. They can get whatever certificate says, oh, here's the latest hash of that thing. Now, it
right.
doesn't give you the hash and the key to decrypt it. It just gives you the hash to be able to get the file. And then you can imagine the read thing being built on top of that as being here's the hash and also the key to read it. But then the read write capability is actually the hash, the key to decrypt it, but also the key to encrypt. So
Right.
if you get the private key to become a writer, right? You
Right.
get handed all those things. So writers basically get a key to be able to keep writing to these certificates. Now you could do something more like ZCAP-LD where you sign off on future people being able to get access and stuff like that.
Mm,
But Tahoe takes a fairly elegant approach of we're just assuming if you give somebody right access, you're just giving them right access.
yeah.
And if you want to make a new file that they can't write to, you just make a new file and then they can't
Mhm.
write to it, right? Um, but it's brilliant. Like it's like a very simple mechanism, and really powerful and way ahead of its time. Like
Yeah, I
Tahoe
feel like
did
I've been waiting for someone to build that on top of IPFS, and I don't know why there isn't something like that on
so
it yet.
someone has let me link
Okay, good.
it's ERIS, an encoding for Rust immutable storage. I'm
Huh.
gonna put it in the chat, and maybe you can put it in if there's show notes or whatever. You can put it in there.
Okay.
But this is by Pucka Mustard. It's great.
Eris.
And it does work on top of IPFS. There's a different one that allows, so this is for the immutable objects, and there's a different one for the mutable ones. But that's a topic for another time. And in the long-term plan of Spritely, actually, um, we plan on having two different answers for things. One of them is, how do you do distributed behavior? And that's goblins. Goblins is distributed behavior. And
Mm.
the other one is, do you do distributed data, and that's what we
Right.
call Porta and Bella, like
Mm.
Portabella. Like the and Porta is like the immutable part, and Bella is like the mutable part.
Mm.
The visual metaphor that we had for those for a long time is that, like, you can imagine the portable version as being like a mushroom that, like, they populate all over the place. You have these mushrooms, hard to get rid of them, but you can have lots of these mushrooms, right? In order for them to update, it's like there's a vine that points at what's the latest version of this mushroom, right? Like what's the um so we need a mechanism. We are looking currently at ERIS as being that mechanism. It's compatible with IPFS.
Hmm.
And the I believe the mutable version that's on top of it, which I'm blanking on the name of at the moment, also is compatible with that. So it's totally possible to build that. There's no reason why you can't have that. Um, but what was really brilliant about Tahoe is that it pre-anticipated a lot of this stuff. Like they did that first. Before they didn't just do a content address thing that you layer it on top of. They just launched a content address thing with that already thought about from the very beginning, which I
Nice.
really I really admire the people who worked on that project for having such incredible foresight.
Hmm. Awesome. Cool. Well, I feel like we just did a really fun whirlwind tour of a bunch of our favorite things, and it was good to catch up. I feel like there's a million other little things to get into, but a lot of it is just going to be like all the fun that we'll have as we bring these systems online. And yeah, so I guess to anybody who's watching this, look forward for these systems because it'll be a new way to interact and write programs together or just socialize and build networks and communities. And um, yeah, so thanks for being part of my community, Christine. It's always so much fun talking to you, and I learn a ton. I feel like I get like you know, this is my little computer science special university course. Um, and yeah, it's the absolute dream to get to work with so many great people like yourself. Um,
Likewise, likewise. I love our calls, and it's fun to do this one. Which, I mean, if you're listening to this, then I suppose we did end up sharing it.